This is section 6.4, special parallelograms. We're going to learn about the properties of a couple special parallelograms. In this particular case, rhombuses, which I sometimes call rhombi, and rectangles. First special property that we want to see is that each diagonal of a rhombus bisects two angles of the rhombus. I have rhombus ABCD up here. I know it's a rhombus because all four sides are congruent, and I've already drawn the diagonal. It should be pretty easy to see that triangle 1 and triangle 2 are congruent by side, side, side. Because the two triangles are congruent, their corresponding parts are congruent. This could be a corresponding part of triangle ABC, and this could be a corresponding part of triangle ADC. So the two angles are congruent. That means that the diagonal must have bisected angle A. By the same argument, we could find out that the diagonal bisects angle C. So whatever the measure of angle BAC is going to be the same as the measure of angle DAC, DCA, and BCA. All four of those angles will have the exact same measure. Okay, what might I ask you algebraically? Well, I may say this angle is x minus 5. This angle is 100 minus 2x. What is the measure of angle BAD? We know, because each diagonal of the rhombus bisects the angles, that these two angles must be congruent. So x minus 5 must be equal to 100 minus 2x. Adding 2x to both sides, 3x minus 5 is equal to 100. Adding 5 to both sides, 3x is equal to 105. Dividing both sides by 3, x is equal to 35. If x is equal to 35, x minus 5 is equal to 35 minus 5, which is 30. By the way, this angle BAC, 100 minus 2x, better be 30. Sure enough, 100 minus 2 times 35 is 100 minus 70, which is also 30. The two angles were bisected. They're both 30 degrees. I'm looking for the measure of angle BAD, which is the larger angle. The angle addition postulant says I can add the 30 and the 30, and the measure of angle BAD is 60 degrees. The first property of the rhombus that we wanted to look at, each diagonal of a rhombus bisects two angles of the rhombus. All right, next property. Okay. The diagonals of a rhombus are perpendicular. Okay. The good thing is we just figured out that the diagonals of a rhombus bisect their angles, and so when I'm looking at this rhombus, and I've already drawn both the diagonals, these two angles must be congruent. These angles are congruent. These angles are congruent. And these angles are congruent by what we just did on the property before. Well, if that's the case, all four of these angles must be congruent by angle side angle. If they're congruent by angle side angle, all their corresponding parts must be congruent. Well, 1, 2, 3, and 4 all end up being corresponding parts. 1 and 2 are congruent, and they are linear pairs, so they're supplementary. Because they are congruent and add up to 180 degrees, 1 and 2 must both be 90 degrees. The same for 3 and 4. The diagonals of a rhombus are perpendicular. They make four 90-degree angles. All right, what might I ask you about that algebraically? Well, I could say that this piece of the diagonal is 3, and AD is equal to 5. And I may ask you, what is AC? I'm going to use the property that the diagonals of a rhombus are perpendicular to see that I've got a right angle here. Because I have a right angle, that has made a right triangle. I'll call this E. I have a right triangle, ADE, whose hypotenuse is 5. One of the legs is 3. Hopefully you recognize this as a 3, 4, 5 triangle, but if not, we could still do the Pythagorean theorem. I would call this side B, 3 squared plus b squared is equal to 5 squared. 9 plus b squared is equal to 25. Subtracting 9 from both sides, b squared is equal to 16. B is equal to, taking the square root of both sides, b is equal to plus or minus the square root of 16. I don't need negative numbers when I'm talking about distances. The square root of 16 is 4. And so b is equal to 4. AE is equal to 4. Well, because I have a parallelogram, and rhombus is always a parallelogram, if AE is 4, then EC is 4 also, and the length of the segment AC must be 8. Property number 2, the diagonals of a rhombus are perpendicular. Property number 3, this time instead of having a rhombus, I have a rectangle. I know it's a rectangle because I see that all 4 angles are right angles. And the property that we want to talk about is that diagonals of a rectangle are congruent. The way I'm going to prove this is I'm going to separate this rectangle into 2 triangles. Over on the left-hand side, I am going to have, doesn't look much like a triangle, does it? I'm going to have A, B, D. And on the right-hand side, I am going to have C, D, A. Okay. Both of these are right triangles. I was thinking hypotenuse leg, but probably won't need to use that here. Because it's a rectangle, all rectangles are parallelograms. I know I have a parallelogram. Because I have a parallelogram, opposite sides are congruent. AB must be congruent to CD. Also, by the reflexive property, notice that AD has to be congruent to AD, reflexive property of congruence. The right angles, all right angles are congruent. So these 2 triangles are congruent by side angle side. If the 2 triangles are congruent by side angle side, all their corresponding parts are congruent. So therefore, by CPCTC, BD must be congruent to AC. That's what we were trying to prove. This diagonal BD is congruent to this diagonal AC. The 2 diagonals of the rectangle are always going to be congruent. What might I ask you? I might say, okay, AC is equal to x squared, and BD is equal to 10x minus 25. And what would then be AC? Yes, I know it's x squared, but I actually want a numerical value. Because the diagonals of a rectangle are congruent, I can set the 2 numbers equal to each other, in this case expressions equal to each other. X squared is equal to 10x minus 25. It's a quadratic, so I'm going to put everything on the same side of the equation. X squared minus 10x plus 25 is equal to 0. If you recognize this as a perfect square trinomial, you can easily say it's x minus 5 squared. Otherwise, I'm looking for 2 numbers that multiply to give me 25 and add together to give me negative 10. Well, my factors of 25 are 1 and 25, negative 1, negative 25, 5 and 5, negative 5 and negative 5. Those are the factors that will multiply to give me 25. The ones that add together to give me negative 10 are negative 5 and negative 5. I can write this as x minus 5 times x minus 5 equals 0. X minus 5 squared equals 0. X must be equal to 5. I didn't ask what x was, though. I asked what AC is. If AC is equal to x squared, then AC is equal to 5 squared. AC is equal to 25. All right, let's try some on your own. If you would, please pause this video and then solve for x. Pause now. Okay, this is a rhombus. Because it's a rhombus, I know it's a parallelogram, so I know opposite sides, also opposite angles are congruent. If the top left angle is 102, the bottom right angle is 102. Didn't really need that, but because I also know that these 2 sides are consecutive angles of, or 2 angles are consecutive angles of a parallelogram, they must be supplementary. So if the top left angle is 102, the bottom left angle must be 78. Because it's a rhombus, though, the diagonal bisects that 78-degree angle into two congruent angles. Both of the angles must be 78 divided by 2. Both of them must be 39 degrees. So the value of x is 39. Problem number 2. I know AC is 2x minus 1, BD is 41 minus x. Pause the video and solve for AC. Pause now. Okay, we know that the diagonals of a rectangle are congruent. If they're congruent, then we can set them equal to each other. So 2x minus 1 is equal to 41 minus x. I will add x to both sides of the equation, and I will get negative 3x minus 1 is equal to 41. Adding 1 to both sides of the equation, 3x is equal to 42. Dividing through by 3, x is equal to 14. They didn't ask me what x was, though. They asked me what is AC. Well, AC is equal to 2x minus 1. I know that x is equal to 14, so I get 2 times 14 minus 1. 28 minus 1 is 27. AC is 27. Practice number 3. If AC is 6 and BD is 4, what's the perimeter of ABCD? Pause the video now and solve. AC is 6, so this big diagonal is 6. BD is 4, so the smaller diagonal is 4. Because this is a rhombus, I know it's a rhombus because I have all the tick marks. Because it's a rhombus, all 4 sides are congruent, and also, by definition, all 4 sides are congruent. That means that the diagonals must be right angles. They must be perpendicular. I have a right angle. If AC is 6, this piece of the diagonal must be 3, half of 6. If BD is 4, this must be 2. I have a right angle. I have 2 legs of a right triangle that are 2 and 3. And I want to figure out what AD is. Well, AD squared is going to be equal to 3 squared plus 2 squared. AD squared is equal to 9 plus 4. AD squared is equal to 13. So AD is equal to plus or minus the square root of 13. I don't need the negative square root of 13. AD is equal to the square root of 13. So I know this bottom side is equal to the square root of 13. It's a rhombus, so all 4 sides have to be the same. AB is the square root of 13. BC is the square root of 13. CD is the square root of 13. To find the perimeter, I add them up. Square root of 13 plus the square root of 13 plus the square root of 13 plus the square root of 13 is equal to 4 times the square root of 13. The perimeter of ABCD is 4 times the square root of 13. Thanks for listening, and we'll talk to you later.